Hi. Okay, I haven't even planned out this video, but I just came out of a meeting with a colleague of mine and realized how easy it is to get started with Fuse, but there are no good examples. And so it's basically about some fault checking, but the thing is, how do you get started figuring out something with Fuse? So you can use Fuse to do some remote fun file system stuff, but this is not what we are covering. What we are doing is we are changing our underlying file system with Fuse, and this is very easy to start. So you just, okay, I don't even have it open. So you just open the terminal, then you clone Fuse. For development, you need two libraries. I have them probably already, but you would do Fuse3 and libfuse3dev. Okay, and then after you install it, you just look into the examples and let me start Tmux here. Here we have the pass-through, which is just the basic. You just use the pass-through, and you can see even here how it works, how you compile it. And then when we look, I wrote some fun stuff there. So how does this all work? So there's this great thing from, I forgot one of the, yeah, Thomas Krenn, AG, where they have the Linux storage stack. And this is how it works. So here you have your applications, and this is your applications, right? And they are calling a write operation because they want to write to disk. And what does this mean? Then it goes to the virtual file system, and then the virtual file system, amongst other things, has to decide, who will actually handle the byte calling. And what it basically does, it looks at the mounts as far as I understand. And for example, you can see dev shared memory, is a tempfs. So it knows, oh yeah, the tempfs is handling that. And for example, if I would have like a sys, like Windows mount or an NFS mount, then I could see the NFS mount is at MNT blah 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 or a USB stick, and it goes to USB file system, says here was the write operation. Great. So the easy thing that you can do with Fuse is you can say, okay, I take that operation and I apply it on the underlying file system again. And this is the basis you can work with. And furthermore, with Fuse, the great thing is, so usually you can see, this is like the application. Here we are, below here we are already on the kernel stack. So this is kernel code, and kernel code is horrendous. I think you can't malloc there, and everything has to be very fast, and you can destroy other drivers because there's no like security, and you have to recompile your kernel module, and it's very complicated. And so when you just play around with IO storage, you use Fuse. Fuse, I think it's somewhere here as well. Yeah, here. So Fuse is a kernel module that talks to another program. So how it works? There's also from Wikipedia. There's a great thing about the Fuse structure. So you have your own program here. And then it goes to the VFS, says, here I want to go to TMP Fuse, which is a Fuse mount. It will then see in the mount table, oh yeah, this is handled by the Fuse kernel module. It goes to the Fuse kernel module. The first kernel module then so it looks, okay, which program offered me to manage that? And this is your file system. It then talks over a special device called devfuse. So libfuse is just so this is the communication port basically between the kernel fuse and the libfuse that you build your file system with. It then tells your program, here's the read operation, please handle. You handle it, it goes back, it goes back, it goes back. And what the pass-through system is doing here, it does your file system does another I/O call to the underlying file system, and then it just passes it through. This is very easy to start. This is everything we have to know. One more thing we have to know. Let's first compile it. So let me do something. Oh, I already have it open. Let me do something very funny. So we go and so how it works. let's look at the main first. We have the main function here, and it does some blah 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 blah. It has two special parameters, but except that, it just gives the argv and gives it to the fuse main. The fuse main, don't have autocomplete here. I can get autocomplete here. Let me take that thingy. Let me write bear in front of it. And I now have autocomplete. Great. So the fuse main is also just a macro, but the fuse, so what you're basically doing is you do your own handling, initialization stuff, and then you tell fuse, here you take over now. And you can give another arguments to fuse itself. And the most important thing that you give over is the fuse operation struct, which is here. So the fuse operation struct is a struct of function pointers. This is also the main point you should look at. You can find some documentation here, but you can also, if you have your editor set up, here as you can see, it describes how you do error handling and then what each of the operations are doing with some footguns. And what you basically say is, hey, if for my file system someone wants to do a read, I call fuse, please just call the read function, libfuse, please just call the read function that I gave you. So the read function here, which is a function pointer to a const char, a size t and off t, and a struct file info, please call my read function here. So then, it gets to the VFS. The VFS gives it to fuse because the bind is fuse. Fuse looks up which libfuse client in user space offered me that mount point, and it sends that to that one through defuse. Then the libfuse client in user space looks, oh, which function did my programmer give me for read? It goes to that function. That function does its stuff, returns afterwards here the result. And then the result goes back the stack through libfuse, through defuse in the kernel, through the VFS back and back. Great. So the basic thing that you have to understand is the fuse operation struct is where you tell fuse, hey, just call this function. And as you can see, for example, when I do a read, let me also write here that I want to do a printf of lol read got called with, and let's take the path. Okay, now you can recompile it. Do I still have it here? Yes, great. And now you have to understand, so as I told you, that the argv, so the parameters, are just passed through fuse. So fuse has two very interesting parameters to call, to also put in there for debugging. So you can do -f. Fuse knows what it means. -f means stay in the foreground. Don't, since you give it back to kernel space, you can theoretically exit, but no, stay here with me. I want to see what the outputs are. And then there's d for debug, where it shows you each IO call that was done, but we leave that out for now. And then you, of course, need to say where it should be mounted. Let me put here, make the test mount. And when we do pass through -f so that we see what happens. With libfuse example test mount. Great. Okay. And then we can see in test mount. And we see our root file system again. Why does this happen? Why does it show the root file system? This is very easy because, let me just, shit, I can't really read binary stuff. Let me touch a test, echo, haha, test file, cat test file. So as you can see, it gets called, here you can see the print, it gets called with tmp test file. Why does it get called with tmp test file instead of home with libfuse example test mount tmp? Because fuse gives you the root from your mount point. As we can see, if we mount and grep for I think if we just mount, we can see pass-through is mounted to test mount. So test mount is the root from the file system perspective. Thus, it only gives you the relative path from that point on. But this is very fun. So now you can just play around and you can override every function. So for example, let me go into read. Read could be fun. Can we manipulate something funny here? Okay. We can say that whatever we are doing, instead of doing all that jazz, is period allocating? No, right? No, period can't be allocating. Okay. So lol. Okay. Instead, we just write buff is equal to ha ha he he. I don't know if we need a 0. And then, no, or do we need to strict up? Can we give out that space? Okay, let me do buff 0 ist gleich L. Why is it oh yeah, I wrote too much go. So 1, 2, 3, O, and \0. And then we say the size is equal res returns how many bytes, if I remember correctly, is returning 4. Great. So now we should be able to recompile, remount. We should, before that, go out. Remount. With libfuse example test mount tmp, and we can read test file. Why didn't it trigger the read function? So, but what we can now do is we can also look at, I should leave the -d, and we can see which operations are called. Well, you can see there are always operations called because I have this libfuse example test mount tmp cat test file. So what operation does it call? We make some space here. It calls a read. Oh, I know why it was, because I don't return. I'm so stupid. Return res. Does it return res? Probably it returns res. So now we have short-circuited the function, hopefully. Okay. Recompile, remount. But this is how you're developing. I mean, this is the bread and butter of it. And now I can do cat test file, and instead, here you can see I override the read function, and you can do whatever you want. You can do a curl request. You can fetch some API source. You can have in the read dir. So there's the underscore read dir. In the read dir, this is some optimized one, but you can just return the pointer. So this is the operation that ls calls underlying. So you can just invent some fancy names that are not even related to real files, and if you cat that file, you, I don't know, do call to this, and then it gets printed out this, and we can see we are fucked. Yeah, but anyways, this is how you just hack around in it, and you for example, what you could also do is let's say you have some fancy extra program. You could say if the path, so jar handle differently prefix. So you can say if it starts with tmp, my fancy folder, great, and then you count how long it is. N is string of handle different prefix, and then you can say if str and cmp. So if the path starts with the handle different prefix. Then do some hilarious stuff as just run normal IO. And this is how you start playing around. You add extra functionality. You can add extra extended attributes for some stuff. You can track stuff. I have my file system that tracks how many IO operations are done and then streams it to some time series database. But this is how you start. You just take this passthrough.c, you compile it, and then you take each IO operation that you want to change. And this is everything that you have to know. Beyond that, you will figure stuff out, honestly. It's very easy. And I think that's all I want to say. Again, don't forget the -d, -f. They are very useful to debug. And enjoy.